This video is going to introduce coordinate geometry, and it's going to particularly look at the coordinate plane, which should be just revision from junior cycle, so I'm hoping that this video will be nice, short, and it will make 100% sense. So the best way when we're starting this chapter is to visualize exactly what's happening. And the best way to do that is think of the desk where you're sitting in school, and it looks something very similar to the one that's drawn here on the board. And think and imagine that your desk is reaching in every single direction. So it's coming through your body, it's going out towards the whiteboard, it's also going out towards the walls of the classroom. So when it gets to the walls, it will go straight through the walls. And also think about your desk, it could also go straight the way up as well. So your desk, it could come right the way up and go through the ceilings or go right the way through the floor. When it's gone through the walls, it's obviously going to be outside, so it's going to be stretching right the way through the school gardens, the car park, out towards the road, and it's going to keep on going. It will go through the hills and through the mountains. It'll go maybe towards America, towards Britain, towards France, and up towards Scandinavia. So also we had the fact that it could stretch upwards, so it could go right the way through the ceiling, it would then go into the attic of the school, it would then go out into the open, through the air, up into our atmosphere, and out the way into space. Of course, it could also go below our desk, so it could go down into the soil, right the way into the mantle, and the core and the inner core. So basically what we're saying is that it could go literally everywhere, in every direction, forever. And when this happens, we have what we call a plane. Now, in mathematics, a plane is just a flat surface that goes on forever in every single direction. And we call this plane the coordinate plane. And right here, I have the coordinate plane drawn. So we have two lines that go in two directions forever. So for example, the line here that's drawn across the page goes right the way across the page. It would continue out towards the walls on either side of the room that you're in, and keep on going to infinity in either direction. As well, we have the lines that is horizontal, so it would obviously come down and keep on going through you and out the other wall in your room, and it would go on forever, or it would keep on going out maybe through a window and keep on going into your garden and into the mountains. So the person who discovered this was a famous mathematician, and his name was René Descartes. And how he came up with it is, one night he was lying in his bed and he saw a fly on the ceiling. And what he wanted to be able to do is he wanted to be able to describe exactly where that fly was. So instead of just being able to say, oh, it was kind of over there on the left or it was over there on the right, he wanted to pinpoint exactly where that fly was on the wall. So this just gives you an idea of kind of what he saw. So he was sleeping, he looked up and he saw something similar like this. He saw the fly on the wall. And he kind of knew that he couldn't say it was to the left or near the right or in the middle. So he described the position of the fly using a coordinate plane. And we're going to see exactly how he did it now in 2 seconds. So what he did was he looked up on the ceiling and he kind of drew out this coordinate plane. And he could see that the fly might have been in this direction here. So the fly might have been exactly here. And what he was able to do then was he was able to tell exactly where that fly was. So if someone came in and said, right, well, where was the fly, Rennie? Where did you see it last night? He's able to say, well, it was kind of 5 units to the left and 5 units upwards. So 5 units to the left, so it kind of corresponds to this, and it was 5 units upwards too. So it made it much easier to describe where the fly was, instead of saying, oh, it was kind of up to the left a little bit over there. It was much easier to say, well, it was 5 units to the left and then it was up 5 units too. So the coordinate plane is divided into kind of 2 number lines, and it's something that you should be able to remember from primary school, and this is definitely something that you saw in first year too. So the first one is horizontal, so it goes across the page, and this is the one that will go straight away out either side of your laptop or your computer, whatever you're watching this device on. And the other number line that we have is vertical, so it goes up in the positive direction and the negative direction, and the positive direction always goes up and the negative direction always goes down. And when you join the 2 number lines together, you get something like this. So we have the horizontal number line here, and we have the vertical number line here. So you can see that the vertical one, all the numbers on the positive side go up, and all the numbers on the negative side, they go down. Then for the horizontal one, obviously the positive numbers kind of go to the right and the negative numbers go to the left. So the coordinate plane has an infinite amount of points. So there is billions and billions and billions and trillions of points on the coordinate plane. And what we have to be able to do is we need to be able to say exactly where some of these points are. So as you can see here, I've kind of littered the coordinate plane here with loads and loads of points. And what we're going to learn to do next is we're going to learn to say, okay, well, this point is on this place of the coordinate plane, or if I asked you to plot a certain point, you should be able to do it no problem at all, and that's what we're going to learn in this video. So the origin is the point right in the center, so where the two number lines meet. So they only meet in one place, and it is right here, and the origin is the name we give to that point where the two number lines meet. So mathematicians, they decided to name these number lines. It's much easier to name them than just calling it the number line that goes across the page or the number line that's horizontal. So what they've called it is they've called the number line that goes horizontal across the page the x-axis. And then they've called the vertical number line the y-axis. So here we have the x-axis, and up here this is the y-axis. So when we have the two number lines, let's have a look at them again. This is our vertical number line, and this is our horizontal number line. And we should know the names of them now. The horizontal number line is called the x-axis, and the vertical one is called the y-axis. What happens when we have these is it kind of divides the page into four. So you can see that we have this section here, this section here, this section here, and this section here. So there's four kind of sections to the page when we draw both the vertical y-axis and the horizontal x-axis. So just to kind of get rid of this. So how we label it is the quadrant that's on the top right is the first quadrant. Then the second quadrant is to the left of that, and then it kind of goes around in a circle. So you kind of start at 12 here and work anti-clockwise to label them. So the first quadrant being in the top right, and then it works the way around anti-clockwise to get the second, third and fourth quadrant. Now, so what we need to be able to do is we need to be able to look at the coordinates that are on a coordinate plane, and they're always written in brackets with the x value first. So they're always written like this, and this is hopefully just revision from first year. So we have our coordinates here, and it's always written the x value, and then afterwards is the y value, making sure that we know the x-axis is on the horizontal number line and the y-axis is on the vertical number line. So we're going to get used to plotting a few different points. So the first one we have here is to consider the point which has the coordinates 4, - 2. So the first number tells us how far to move along the x-axis. If you look along here, we have the point 4 - 2. So the 4 corresponds to the x value, and the -2 corresponds to the y value. So the first number tells you how far to move along the x-axis. So you can see here that I've moved 4 spaces. So 1, 2, 3, 4. And we always start at the origin. Remember that the origin is where the two number lines meet. As well, we have our x-axis, which is horizontal, and we have our y-axis, which is vertical. So the 4 in 4 - 2 says we need to move 4 units to the right. So we have moved 4 units to the right here. So the second number tells us how far to move up or move down. So we have the point, remember, 4 - 2. So the -2 in the 4 minus 2 tells you to move down 2 units. So we've moved across 4 and now we move down 2 units, and we've now plotted the point 4 minus 2. And when you plot a point in coordinate geometry, you always need to say exactly where it is and what it is. So you've put the point there, and you also need to put in the brackets. So if I was to say to plot the point 7, 5. First of all, we need to know that 7 is our x and 5 is our y. So the x value tells us how far we have to go across. So for 7, we go across 7. So we've gone across 4 firstly here. So 2, 3, 4, 5, 6, 7. So this is where 7 is. And then the y value tells us how much we have to move up or we have to move down. So we have 5 here. So what we're going to do is we're going to move up 5. So 1, 2, 3, 4, 5. And we have 5 here. Now, of course, yours will be much neater when you do it in your copy. Because I'm doing it on the board here, it's not as neat. So we've our point there, but we need to label the point as well. So we always just write in 7, 5. So one thing that people find a little bit difficult is when they're asked to plot the point 0, 0. So to get from the origin to the origin, we don't move at all. So it just stays right at the center point here, which is perfectly fine. And we just label that then 0, 0. So give the coordinates of each point. That's definitely a question that you might be able to ask. So making sure that we have, so here's our x-axis, and that's our horizontal one. We have our y-axis, which is our vertical one. And what we have to do is give the coordinates of each point. So we have our x and our y. So first of all, for x, we need to figure out where it is on the x-axis. So we're looking at point 1 here. So we're going to put this down here, 1. We have our brackets and there's a little comma in between it. So if you look at 1 here, if we go back up to the x-axis, it corresponds with minus 6. So we had to go minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 out to it. So for 1, we have x is minus 6. And then we have to look at the y-axis and see how far it comes down on the y-axis. And if you look over here, it came down minus 1, minus 2, minus 3, minus 4. So we have 1 is 6 minus 4. 2, we do the exact same thing. So first of all, we're going to look at the x. So to get to 2, we went 1, 2. And it's minus 2. So it's going to be minus 2 here. And then to get up to it, we went 1, 2, 3, 4. So that was going to be minus 2, 4. Point 3 then, so point 3 is down here, and what we're going to do is we have to figure out how to get out to there. So for this we go 1, 2, so this point here is positive 2, and then we have to go down 1, 2, 3, 4, 5, 6, and we've gone down 6, so it's minus 6. So that's 3. 4 then is next. So for 4, on the x-axis we have to go 1, 2, 3, 4. So it's going to be 4. And then we have to go up 1, 2. And finally number 5 then. For 5, we do the exact same thing. So we have to go out and we have to go, this is 1, 2, 3, 4, 5, 6, 7, 8. So for 5, we went out 8. And then we come down 1, 2. So it's minus 2. So then if we look at the coordinate geometry worksheet that you're going to be working on, it kind of goes through it. So it's all based on the coordinate plane. So everything we've been looking at so far. And it talks about the x-axis first. And remember that the x-axis goes along the line, so it's the horizontal axis. And the y-axis goes along the wall, which is the vertical axis. So remembering that we always label them x and y, and when we're plotting a point or reading a point, we always go along the road and then up the wall. So I have a few examples that I'm going to go through to make sure we're okay with it, and then hopefully you should be fine when you're answering these questions. So example 1, so it says write the coordinates of A, B, C, D, E, F, G and H. So we look at A, so making sure first of all that we have to go along the x-axis and then down or up the y-axis. So for A is here, so we go across 1, so then x is going to be 1, and then we have to go down 1, 2, 3, so it's going to be 1 minus 3. Then for B, B is up here, so for B we're going to go across the x-axis 1, and it's in the to the left, so it's going to be minus 1, and then we're going to go up 1, so it's going to be minus 1, 1. So that is A and B done. Then if we look at C, C is over here, and to get to C we go 1, 2, 3, 4 along the x-axis, and that's minus 4, and then on the y-axis we come down 1, 2, so then that is minus 2. So D is next, and for D we go across the x-axis 1, 2, 3, 4, so this is 4, and then we come up 1, 2, 3, 4. Now E then is next, so I'm just going to get rid of this drawing out of our way. E then, we come across the x-axis 1, 2, so then this is minus 2, and we come up 0, so it stays at 0. F then is next, so we go across the x-axis 0, because it's on the x-axis, and then we come down 1, 2, so it's minus 2. So the next one then we have is G, and for G we come across 1, 2, so it's going to be 2, and then we don't do anything on the y-axis, so it stays as 0. The last one we have then is H, and H is here, and for H we don't do anything on the x-axis, so that stays as 0, and then we come up 1, 2, 3, 4. So example number 2, it says here plot the points S minus 4, 2, T 0 minus 3 and Q 4 minus 1 on the coordinate diagram. So what we have first of all is S minus 4, 2, so that is our X and our Y. So X is minus 4, so we're going to go minus 4, so 1, 2, 3, 4, and then the Y is 2, so we're going to come up 2, so 1, 2. So this point here is S, which is minus 4, 2. And I'm going to just rub out the rough work I have there. The next point we have is T, which is 0, minus 3. And this is our X, and this is our Y. So for this, X is 0, so it stays here at the origin. And then Y is minus 3, so we're going to come down 1, 2, 3. So this then is our point T, which is 0, minus 3. And again, I'm just going to rub out the rough work there to make it a little bit easier. Now, and then the final point that we have is Q, which is 4, minus 1. So here with Q, we go across 4, so 1, 2, 3, 4, and we come down minus 1. So it's going to be here. So then the point here, Q, is 4, minus 1. Now, so the questions you're going to be doing by yourself. So question 1 says, write down the coordinates of each of the points marked in the coordinate plane below. Very similar to the first example that we did there. So if you go back, have a look at that, maybe take down a few examples, and then do that question. It should be fine. Question 2 says draw a similar grid to that shown above and mark in the following points A, B, C, D and E. That should hopefully cause no issues too. It's very similar to example 2 that I did for you there. Question 3 says the 4 quadrants are shown below. In which quadrant does each of the following lie? So we have 3, 5. So I'm going to do the first one for you. So if you look at 3, we'd have to go across the x-axis 1, 2, 3 and up 5. So 1, 2, 3, 4, 5. So if we were to see which quadrant that lies in, that's going to lie in the first quadrant. All the other ones here, so -2, -3, 1, -4, -3, 1, they will all be very similar to this. You just go across the x-axis, up or down the y-axis and figure out which quadrant it's in. Question 4, I'll do the first one for you. So it says, which axis does each of these points lie? So here what we have is I've drawn the 2 axes and we have to label them. So this is our x-axis and this is our y-axis. So I'm going to put in a few points. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, and the first point we have then is we have the point 4, 0. So that goes across 4. So 1, 2, 3, 4. And then it goes down 0. So this is going to stay as that point there. So then is this one on the x-axis or the y-axis? This point is on the x-axis. So question 5 should hopefully be okay. So it's just asking you to write down the points A, B and D on the given grid. Then what you have to do in the second part is you have to find the coordinates of C, and C is going to be that it'll make a rectangle, and you have to figure out where C might be if it makes a rectangle. Question 6, it'll hopefully be easy enough as well. It's very similar to question 5. You draw your x and y axis from 0 to 5, you plot the points, and then you're finding a square. So that is the end of this video. If you have any questions when you're doing any of the worksheet or on this video at all, just give me a quick email and I will get back to you straight away.